Hello, today we are going to look at TypeScript. We will build a student app using TypeScript in React. We will look at various aspects of TypeScript like passing props to components, type inference versus type annotation. And in addition to that, we will also go through what is an interface. Towards the end, we will look at generics. We will create a generic sort function that will be used for sorting students' data. Before we jump into the code, let's look at some key definitions. Well, what is TypeScript? TypeScript is a popular and widely used programming language that is built on top of JavaScript. The goal of TypeScript is to write strongly typed JavaScript. TypeScript is converted into JavaScript by using of a compiler like TypeScript compiler or Babel. What are the benefits of TypeScript? One, it is a strongly typed language. In this case, bugs are caught early in development rather than later in production. Also, it provides the documentation for JavaScript code. TypeScript's generics feature gives the developer a lot of flexibility. There are a lot more benefits of using TypeScript. I just highlighted a few of them. Let's go ahead and create a student's app. Among the features that we'll be looking at is props, that's passing of props to components. We'll look at type inference versus type annotation. We'll also look at union types, organizing interfaces. We'll look at enums, and finally we'll go through the generics. I'm creating a new TypeScript React application. I will use the command npx create react app name -- template space TypeScript. If you already have an existing React project that you would like to add TypeScript, please follow documentation in the link provided below. Well, the setup is completed. So now I'll open the app in Visual Studio Code. I'll then go and do some cleanup on the app.tsx. What I want to achieve is on the app component, I'll pass a string, the app name, and it will be displayed on the front end. To achieve that, I'll pass app name and it will be of type app name. I will then create app name interface with a property called name. I will display the app name with a h1 tag, a student app. I will hit the save button, run the app now. As you can see, student app is displayed. So we've seen the first use case of TypeScript. I will go back to index.tsx. I will change the app name, currently it is a string, and try to put in an integer and a boolean value. As you can see, immediately it is showing an error, and that's the power of TypeScript. We can't use any other type besides a string for the name. I will go to app.tsx. Using the useState hook, I will initialize student ID value to an integer. I will go ahead and set student ID to a string. As you can see, an error pops up. This is referred to as type inference, where TypeScript infers the type of student ID to an integer value. Similarly, I will use a useState hook and initialize a student object to a null value. I will then set student to a student object with a property name, surname, and age. As you can see, it pops up an error. This is because through type inference, TypeScript expects the student to be of type null and not an object. Now that we want it to take the shape of an object, I have to use an interface to define the student object. This is what we refer to as type annotation. Through type annotation, the useState hook, in the useState hook, we will define the type to say that the student object can either be a null or can take the shape of a student interface. We have used the pipe operator. This is what is referred to as union types. Union types is when an object can be of different types. In our case, it can be either a null or a student. I will add additional property address to the student object. It will be optional, just like the age. I would like to display the name and surname of the student, and to do that, I will put a paragraph tag. I will add a button. On click, it says the student's name, surname, and age, and display the value. I will set up the onClick function on the button, add student. When we click this, we will set the name, surname, and age, and display on the front end. I will go ahead and save and run the app. As we can see, when I click on this button, the name and surname, they are displaying. This will form the basis of our next discussion. As your TypeScript app grows, your number of interfaces will grow as well. So how do we organize these interfaces? As we can see, at the moment we have the app name interface, we have a student interface. So there are two problems with our current setup. Number one, the student interface has a nested object called address. To fix that, address should be on its own interface. Now we need to move our interfaces to a separate module, in this case a separate file. This is because it will make it easier to manage the interfaces. And also these interfaces, they are not only to be used in the app component, but can be reused anywhere within the app. Let's look at enums in TypeScript. Enums is a type, an enumerated type, and its purpose is to hold a set of constant values. Let's look at an example. In our student interface, let's add a level, which will denote a student is either undergraduate or a postgraduate. We can have an enum, which we call level, and takes constant values undergraduate or postgraduate. Let's add some condition here to our app. If a student is an undergraduate, let's display the age. If it's a postgraduate, we will not display the age. So what we can do, we can say student.level is equals to undergraduate. But what will happen if for some reason you misspell the word undergraduate? It will bring a problem and it will not actually give an error. What will happen is system will have a bug and we might not be able to pick it up. So let's rewrite this with an enum. So it will be student.level is equals to level.undergraduate. When we go this way, we eliminate this type of bugs. Generics is a powerful feature that is used to write reusable code in TypeScript. In our case, I would like to display a students list and a courses list using a single component. As you can see, the student list and the courses list, they both have different properties. Let's have a quick look of how the display of students list look like. I will go ahead and create a new component called display data that will be used to display data for the students list and for the courses list. I will create a component display data that takes its display data items of type T. I'll create an interface display data item of type T that takes an array of type T. And here, T means the object can be of any type. I will then iterate through the list of items, display the records. In the app.tsx, I will use the component display data and pass the students list to the item prop. Similarly, I will use the same component for the courses list. As you can see, the students list and the courses list are both displaying. This is a powerful feature and is very useful in writing scalable React components. And finally, let's look at a generic sort function. For example, in our students list, we might want a situation whereby you click on the name, it sorts the list by name. You click on age, it sorts the list by age, and so forth. To do that, without generics, you will end up creating a function for each sort. Sort by name function, sort by age function, sort by surname function. However, with generics, we will just create one function. We will come up with a generic sort function. It will take an items array and a key of type T. Using the JavaScript sort function, I will pass A, B, and sort the records accordingly. The key in this case will be the sort column. It could be the name, it could be the age, and so forth. And this brings us to the end of this tutorial. The code for the final solution is available in the link provided in the description below. Thank you for watching.